Right, a past examination paper question. So this was taken from Edexcel. It's a core mathematics C4 paper question from the year June 2008, and this was question 7 from that paper. So let's have a read. Part A, express 2 over 4 minus y squared in partial fractions. So let's try part A over here. So we need to express 2 over 4 minus y squared in partial fractions. So 2 over 4 minus y squared. Now looking at the denominator, 4 minus y squared, I can write 4 as 2 squared minus y squared, and 2 squared minus y squared is a difference of 2 squares. So since 2 minus y squared is a difference of 2 squares, I can write that as 2 minus y into 2 plus y. Now, since that's the case, I can rewrite this in partial fractions. So let me copy that down. So I have 2 over 2 minus y into 2 plus y. Now we have the case in partial fractions where we have linear factors in the denominator, and if we have linear terms in the denominator, we can write this as a divided by one of these linear terms. So I'm going to take that as 2 minus y, always plus in the middle because partial fractions is a summation, so always plus in the middle, be divided by the remaining linear term, which is 2 plus y. So just to remind you, this is the case in partial fractions whereby we've got linear factors or linear terms in the denominator. Now let me call this resulting equation star. Now a and b in this identity are values that we need to work out. So these are constants that need to be found. So to work out these constants, what I tend to do is I then multiply this entire equation by whatever term appears in the denominator on the left. So I've circled the term in the denominator on the left hand side in green, and I'm going to multiply star by that very term. So if I multiply star by 2 minus y into 2 plus y, and if we carry forward the multiplication of this entire equation by this term, we're going to have 2 on the left hand side. That is equal to a into 2 plus y plus b into 2 minus y. So this is what you should have when you multiply star by this term here, which appears in the denominator of the fraction on the left hand side. Now from this point forward, we need to choose values of y in this case in order to get rid of one of the unknowns to work out the other. So I'm going to take y, for example, to be 2, okay, as 2 minus 2 is 0, and this would get rid of this b unknown to work out the a unknown. Okay, you can just as well take y to be minus 2 to get rid of a in order to work out b. So let me take y to be 2 to get rid of b first to work out a. So if I put y is equal to 2, so by doing that, 2 on the left is equal to a into 2 plus y replaced by 2 plus the b into 2 minus y replaced by 2. And we chose 2 again, as 2 minus 2 here is 0, and that will get rid of this b term. So we have 2 on the left, which is equal to 2 plus 2 is 4, 4 times a, which is 4a. And if I rearrange further, a is going to be 2 over 4, which is half. So that should be the value of a being half. Now let me replace a by half in this previous equation here. Let's see what we're going to get. So for the left hand side we have 2, 2 is equal to a replaced by half, so half into 2 plus y, plus b into 2 minus y. Now to work out the remaining unknown, so if you've got one unknown to work out that remaining unknown, you can choose any value of y, so any value of y except the one that you've taken from earlier. So you can choose any value except y equals 2. Because if you take y equals 2, it doesn't make sense. 2 minus 2 is 0. That will cancel this b. And we need to work out b. So you can choose any other value of y. I'm going to take y as 0. So I'm going to put y is equal to 0 to work out the unknown b. But as I said, you can choose any value of y except the one that you've used. So by putting y equals 0, we got 2 on the left. That is equal to 1 over 2 into 2 plus y replaced by 0, plus the b into 2 minus y replaced by 0. If we simplify further, 2 is equal to 2 plus 0, so that is 2, and half of 2, that would be 1, plus b times 2 is 2b. And if I rearrange further, so if I take the 1 to the opposite side, 2b is equal to plus 1, and therefore the b value, so the value of the constant b, when I rearrange further, b is half also. So let's go up. So let's replace the a and b in star. So a is half, and as for b, b is half as well. So let's replace it in star. So we got 2 over 2 minus y, 2 plus y. So let's conclude. So 2 over 2 minus y, 2 plus y, and that is equal to, so a is half, so it's going to be 1 over 2 into 2 minus y. So we're going to have 1 over 2 into 2 minus y. And b is half, so upon replacement we'll have plus 1 over 2 into 2 plus y. So let's replace, so plus 1 over 2 into 2 plus y. So this should be the solution to part A. So part A done. So let me make a note that the A value we had is half, and the B value 2 we calculated as half also. Okay, so simple replacement into equation star. So that completes part A of this problem. Right, now for part B. So let's have a read. Hence, obtain the solution of 2 cot x dy over dx equals 4 minus y squared, for which y equals 0 at x equals pi over 3, given your answer in the form sec squared x equals g of y. So let's attempt part B. Let me attempt part B over here. So we have this differential equation, 2 cot x dy over dx, and that is equal to 4 minus y squared. First of all, let me rearrange this. Now, if it's possible to rearrange this differential equation in this form, if it's possible to rearrange it in the form py dy over dx is equal to q of x, so if it's possible to rearrange it in this form, we've got a first order differential equation. So FODE stands for first order differential equation. And to solve first order differential equations, we need to use the method of separating the variables. So let me write that down there. So separating the variables. So let's see whether that is the case. So let's see whether we can rearrange our equation in this form. Right, so back to my favourite colour, blue. So I'm going to take the 4 minus y squared term to the left, and at the same time I'm going to take the 2 cot x over to the right. So if I do the rearrangement as discussed, I'm going to have 1 over 4 minus y squared, let me keep that in the bracket, dy over dx. And taking the 2 cot x to the right, I've got 1 over 2 cot x. So let me be as neat as I can. So this is what we'll have as a result of the rearrangements. And as you can see, this equation here is indeed of the form py dy over dx equals q of x. So here's our py term, our function in terms of y in other words, and here's our qx term, our function in terms of x. Okay, I'm going to go one more stage. So further to that, we know that in trigonometry, cot is the reciprocal of tan. So 1 over tan gives us cot. So as a result of this, so bearing this in mind, let me rewrite this differential equation as 1 over 4 minus y squared dy over dx. And that is equal to the 1 over 2. So let me retain that. Let me keep that as it is. So if cot is 1 over tan, 1 over cot will be tan. So I'll have 1 over 2 tan x on the right hand side. Now, as I said earlier, if we have a first order differential equation, we can solve that using a method of separating the variables. So let's continue. Let's solve this using separating the variables. Okay, so by separating the variables. So separating the variables means that we need to have our y terms including dy on one side of the equation, and we need x terms including dx on the other side of the equation. So generally I put my y terms and dy terms on the left, and I put my x terms and dx terms on the right. Okay, it doesn't really matter which sides of the equation your y's and dy's are and your x's and dx terms are. Okay, so in this case I'm going to keep the 1 over 4 minus y squared and the dy on the left hand side, and I'm going to keep the 1 over 2 tan x as well as the dx on the right hand side. So technically dy over dx is a function, but if you regard that as a fraction, that dx you can move to the right, keeping the dy on the left alongside the y term. And then by doing this, you've got your x terms and dx's on the right and y terms and dy's on the left. Now after separating the variables, we then integrate both sides. So next step, integrate both sides. So we need to integrate the left hand side. So we need to integrate 1 over 4 minus y squared with respect to y. And we also need to integrate the right hand term 1 over 2 tan x with respect to x. Now if we go back to the question, so if we go back to that specific part, it says hence. So hence is a big clue. Hence would tend to mean that you'll need to use one of the answers from the prior part of the question in order to help you with the current part. So we have a prior part. So from part A, we wrote the left hand side in partial fractions. Okay, so we wrote 2 over 4 minus y squared in partial fractions, and in part A we had this as the solution. Okay, so what I'm going to do is, in order to make the left hand side 2 over 4 minus y squared, let me bring this 2 to the left also. So if I bring this 2 to the left, so I'm going to have the integral of 2 over 4 minus y squared dy instead, and that is equal to the tan x with respect to x integral on the right. So we can only move, or you can only move or multiply integrals by constants. So I've just moved this 2 to the left hand side in order to make this fraction the same as this term over here, and by doing that we can replace that term as a result using our answer to part A. Okay, so as a result of this, I can rewrite this integral on the left as the integral of, so let's scroll down a little, 1 over 2 into 2 minus y, so 1 over 2 into 2 minus y, plus 1 over, so plus the 1 over 2 into 2 plus y with respect to y. So that is what we have as a result of the rewriting process on the left hand side. And as for the right, that is still the integral of tan x with respect to x. Now let's go one extra stage. Now let's calculate these two integrals separately. So let me call them integral number 1 and integral number 2. So as a side calculation, number 1. So let's integrate 1 over 2 into 2 minus y with respect to y. Now the 1 over 2 is a constant, so I'm going to keep the 1 over 2 outside. So I've got 1 over 2 kept outside, and inside my integral I have 1 over 2 minus y left to integrate with respect to y. And if you integrate 1 over 2 minus y, you're going to get minus ln 2 minus y add c. So let me add the c for completeness. Okay, so that is what you're going to get when you integrate 1 over 2 minus y. You're going to get minus ln 2 minus y. Okay, but don't forget the half here. So in actual fact it's minus half ln 2 minus y. I'm just adding the c for completeness. Doing the same for number 2. So here's number 2. So if we integrate 1 over 2 into 2 plus y with respect to y. So let's go through this integral also. So again, I'm going to take the 1 over 2 as a factor outside my integral sign. And within the integral, I've got 1 over 2 plus y left to integrate. And if we go one further stage, so let's integrate that. So I'm going to have a half. So that comes from here. And if I integrate 1 over 2 plus y, we're going to have ln 2 plus y. But together with this half ln 2 plus y, let's just add a c for completeness. So here are the solutions to integral 2 as well as integral 1. Okay, and let's incorporate these solutions in this main calculation step here. So for integral 1, we had this. So let's copy that down. So we've got minus half ln 2 minus y. Okay, plus, and for integral number 2, we had this half ln 2 plus y. So plus half ln 2 plus y, that is equal to, and when you integrate tan, the integral of tan is minus ln cos, okay? So I'm going to have on the right minus ln cos x. Let me add the c over here on the right hand side, okay? And let's go one further step. So let me rewrite this as, so if I rewrite the left hand side, I'm going to rewrite that as half ln 2 plus y minus half ln 2 minus y, that is equal to minus ln cos x plus c. So I've just done a switch, so I brought this term to the front and keeping a negative term next to this, okay? And if further to that, if I take a half common factor on the left, so if I take a common factor of half, I'm left with ln 2 plus y minus ln 2 minus y within the square bracket. That is equal to, and as for this term over here, so let me use a red pen, so in the corner, so let me use this space in the corner, so I've got minus ln cos x, that comes from the integral of tan, and I can take this minus to make it ln cos x to the power minus 1. So that is a result of the law of logarithms. So remember the law of logarithms. So if you have log of b to the power n to the base of a, that is the same as writing n log b to the base of a. So using this law of logarithms, I took that minus and rewrote it as a power. So in the sense I went backwards from here, okay? Let me go back to my blue pen, and well, actually, let me keep it to red. And remember, in trigonometry, so sec x is the reciprocal of cos x, and bearing that in mind, ln cos x to the power minus 1, that can be written as ln sec x. So bearing in mind that, let's incorporate it here. So minus ln cos x is the same as ln sec x, adds the c. Now further to that, what we could also do is, there is another law of logarithms that says that if we have ln a minus ln b, that is the same as ln a over b. So I'm going to use this law of logarithms in order to rewrite the term within the square brackets. So as a result of that law, I've got half. So if ln a minus ln b is ln a over b, that would make ln 2 plus y minus ln 2 minus y ln 2 plus y divided by 2 minus y. Okay? And that is equal to the ln sec x plus c on the right hand side. Now let's go back to the question. Let's see what other pieces of information that we have to play with. So if we go back to the question, we've got values over here. We've got the values of x and y. So y equals 0 at x equals pi over 3. Let's use these values to work out the constant c. So let me remind myself, y equals 0, x is pi over 3. So let's calculate the constant c. So y is equal to 0, x is equal to pi over 3. Let's calculate c. So as a result, half into ln 2 plus, so 2 plus y replaced by 0 divided by 2 minus y replaced by 0. that is equal to ln sec, and x is pi over 3, so pi over 3 plus c. Now, as for this term, so let me go back to red. Now, as we talked about earlier, as we discussed earlier, sec is the reciprocal of cos. So sec pi over 3, that is the same as 1 over cos pi over 3. Okay, and let's go one stage further to this. So I've got half in a bracket ln 2 plus 0 is 2 on the top, 2 minus 0 is 2 on the bottom. 2 over 2 will cancel to give us a 1, and that is equal to ln and 1 over cos pi over 3. So 1 over cos pi over 3, so 1 over, and cos pi over 3 is half, 1 over half is 2 plus c. Now if we continue more, even further, ln 1 is 0, and bearing in mind this, 0 times half is 0, so 0 on the left hand side, that is equal to the ln 2 plus c on the right. And if we rearrange further, so if I take the ln 2 to the opposite side, I make c minus ln 2. So that is the solution for c. Now let's plug c back into this equation over here. So let me plug c back into this equation here. Let's see what we're going to get as a result. So on the left, so let me scroll down. So we got half. So half ln, so let me remind myself, 2 plus y over 2 minus y. So 2 plus y over 2 minus y, that is equal to ln sec x. Okay, so ln sec x plus c, and for c we had minus ln 2. So let's replace that c there. Okay, now we're nearly there. If we scroll up, we need to rearrange this, and we need to give our answer in the form sec squared x equals g of y. So g of y means a function of y on the right hand side. So let's rearrange it in this form. Let's rearrange it so that sec squared x equals a function of y on the right. So let me scroll below. So at the moment we have this. Okay, so first of all, on the left hand side, so let's use the law of logarithms in order to rewrite the left hand side. So we got ln sec x minus ln 2, and as a result of this law here, ln a minus ln b, that's the same as ln a over b. So using that law, ln sec x minus ln 2, so I can write that as ln sec x divided by 2. Okay, as a result of that law of logarithms, that is equal to the half on the left, ln 2 plus y over 2 minus y. Okay, and so let me keep that in a bracket, and I don't like this half. Okay, so I don't like the half. Let me multiply both sides by 2. So if I multiply both sides by 2, I'm going to get 2 times half, which is 1. So ln 2 plus y over 2 minus y. And that is equal to, so 2 times the 1 in front is 2. Okay, so it's 2 ln sec x divided by 2. So trying to be as neat as I can with all of my workings. Okay, and further to that, what we could do is we can use this law of logarithms here. So the fact that log of b to the power n to the base of a, that is the same as n log b to the base of a. So we can use that law in order to make this 2 a power of this term here. So as a result of that law, so we'll have ln 2 plus y over 2 minus y on the left hand side. So as a result of that law, we'll have ln sec x divided by 2 to the power 2 on the right hand side. So in order to go from here to here, so remember that rule. So let me rewrite that rule over here, say. So remember, log of b to the power n to the base of a, that's the same as n log of b to the base of a. So we went backwards from this rule to go from here to here. So I made the 2 in front a power. Okay, so let me go back to blue. And actually, let me stick with the red. And if we have ln A equals ln B, we can ignore the ln's. So therefore, A equals B. So using this rule over here, I have ln 2 plus y over 2 minus y equals ln sec x over 2 squared. So we can get rid of the ln's and write 2 plus y divided by 2 minus y, and that is equal to sec x over 2 squared. Right, now according to the question, we need to write this in terms of sec squared x. So let me get rid of the brackets on the right primarily. So I've got 2 plus y over 2 minus y on the left. Sec x squared, so that's the same as sec squared x on top. 2 squared on the bottom, so that is 4. And if I cross multiply, so in this case, if I cross multiply, I'm going to get 2 minus y into sec squared x. That is equal to 4 into 2 plus y. So 4 into 2 is 8. 4 into y is 4y. So let me keep that in the bracket. And if I rearrange for sec squared x is therefore 8 plus 4y divided by 2 minus y. So I believe that that's going to be the answer to this one. So that should be the solution, what they're looking for part B of this particular problem, question number 7. So as you can see, we wrote our answer in the form sec squared x equals a function of y. And we did that very thing. We wrote it as sec squared x on the left as a function of y on the right. So that completes part B. Wow. So that was a large problem. So no wonder it was worth 8 points or 8 marks. So I hope you enjoyed that problem. I hope you liked the video. I hope you enjoyed the problem. If you did enjoy the video, a like is very much appreciated, and be sure to subscribe for more content like this. Thank you.